Good afternoon, everybody. Thanks for joining us for 4-H Live online learning today. My name is Heather Conroe. I am a livestock specialist with the University of Missouri Extension. I'm housed in Howard County in Fayette, Missouri. So part of my job is to provide educational programming for livestock producers pertaining to the livestock animals. I also have a huge passion for youth education, so I was very excited to be asked to provide some programming through this outlet. I also ultrasound for carcass data, which is using the ultrasound machine to look inside the live animal at the meat quality of that animal. And so I do that for county fairs so that county fairs can have a carcass class. And I also do that for producers as well in the seed stock industry. Right now we're going to do the Pledge of Allegiance. So if you would stand and cross your heart and say the Pledge of Allegiance. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. And now let's say the 4-H pledge. I pledge my head to clearer thinking, my heart to greater loyalty, my hands to larger service, and my health to better living for my club, my community, my country, and my world. All right, so the plan for today's online education program is to learn about antibiotic use and residue and withdrawal times. And so what we're going to do is we're going to divide that out into two different topics. We'll watch a video about antibiotics, do an activity about the antibiotics, and then we'll watch another little short video about residue and withdrawal time, and then we'll do another activity regarding to that. So first of all, we're going to watch a video on antibiotics.
What are antibiotics? Sometimes when people think of antibiotics, they picture any pill or injection that a person or animal needs when it is sick to make it better. But not all of these products are antibiotics. An antibiotic is a specific medication that targets and kills bacteria. When an animal or person has a bacterial infection, the correct antibiotic will help them recover quickly. In some cases, administering an antibiotic can be the difference between surviving and succumbing to a disease. Therefore, they are important for animal and human health and welfare. Because of their critical value to producing safe food and ensuring human and animal welfare, they must be used carefully. How do antibiotics work? There are several kinds of antibiotics, and they target different types of bacteria. Some will inhibit the bacteria from being able to form a needed cell wall, and others will interrupt the protein synthesis of the cell. They may break apart the bacteria's replicating DNA or open up the cell membrane so that the bacteria cell dies. By disrupting the processes for bacteria, antibiotics assist the animal's immune system and help them return to good health. We also need to be aware of antibiotic resistance when we use these medications in our animals. Resistance means that bacteria have or develop an ability to evade the antibiotic, and it won't work as well to treat the disease in the future. We all need to be stewards of good health production practices and make sure that we use these drugs effectively and safely. Work with your veterinarian if you think you might need to use antibiotics on your farm. Remember to use the over-the-counter medications according to the label directions. Always follow your veterinarian's instructions for prescription drugs when treating your animal. Also, you should work with your veterinarian to find ways to prevent disease in your animals and reduce the need for antibiotic treatments. Remember, all animal health products are here to assist good management, not cover up poor management. Like any other medication, we need to be aware of the withdrawal time when we use an antibiotic. Withdrawal time is the time for when the animal is given a medication to when it can be harvested or milk can be used without having a drug residue. Residue is the portion of medication that may remain in the animal's body tissues. Antibiotics are important tools for ensuring a safe and wholesome food supply and should be used carefully to ensure their effectiveness. You should work with a veterinarian to create a plan that minimizes the need for these medications and helps you know the right time to use them.
All right, as we learned in the video, antibiotics only work on certain types of infections. Does anyone remember what type? Antibiotics antibiotics are usually the first thing we think we need to take when we or our animals are sick. Antibiotics only work on bacterial infections and not on infections caused by a virus. So let's take a look. That's what our experiment is going to be about today. So each beaker represents an animal. So we have animal A and we have animal B. The noodles at the bottom represent the muscle tissue of that animal. Okay? So one of our animals is going to get sick with a bacterial infection, and the other animal is going to get sick with a virus. So let's go ahead and infect the animal with the virus. So if you take your pinto beans that you have and go ahead and infect your animal, so those little viruses are all over in that muscle tissue in that animal. Man, this animal is sick. Whew, boy. All right, so this animal, again, the pinto beans represent a virus. Our veterinarian has prescribed this antibiotic, and so let's go ahead and treat the animal with the antibiotic. So go ahead and pour some of your antibiotic, also known as water in this experiment, and see what happens to the virus. Does anything really happen to the virus? Is there anything going on really in that? Nope, not at all. All right, so the antibiotic had no effect on the virus. All right, so let's look at the animal with the bacterial infection. So go ahead and take your Alka-Seltzer and let's infect this animal with the Alka-Seltzer. So go ahead and break up your Alka-Seltzer tablet and kind of spread it around in our animal. All right, and then for extra pizzazz, let's go do another one. So if you break that one up. All right. So again, this is a bacterial infection, and the veterinarian has again prescribed water for the antibiotic. So let's go ahead and take our water and pour the water into the, or inject the animal with the bacterial infection. So what is going on there? So as you can see, that antibiotic is having an effect on the bacteria, right? Our Alka-Seltzer is our bacteria. So it's eating away at our bacteria. There it goes. Right? So again, antibiotics only work on bacterial infections and not on viruses. All right. The next video that we're going to watch is about residues and withdrawal times. So we're going to watch a short video on that, and then we'll be back to do another activity talking about that.
The Show Me Quality Assurance program relies on the positive attitudes of producers and students. By participating in the program, youth producers show they are committed to producing top quality food and making responsible decisions while raising their project. Animal health products are used for several reasons, including providing for the animal's welfare by preventing or treating diseases and minimizing production costs. Once an animal receives an animal health product, the animal requires a period of time to clear the medication before its meat or milk can be used for human consumption. In other words, the withdrawal time is the amount of time required for the medication to be metabolized, broken down, or excreted by the animal's body. The withdrawal period is established by the Food and Drug Administration, or FDA, and is based on the results of extensive testing. If a drug has a withdrawal time, it will be found on the label, package insert, or feed tag. Each withdrawal day is a full 24 hours starting with the last time an animal is treated or has had access to a medicated feed, water, topical, or an injectable product.
For example, if an animal is last treated at 9 a.m. on Friday with a medication having a 5-day withdrawal, the withdrawal would be completed at 9 a.m. on the following Wednesday. A residue is the portion of the medication that may remain in the animal's body tissues or in the milk or eggs. Several management practices could cause drug residues. If a medicated feed additive is given, youth producers must be careful to follow the withdrawal times. Another cause of drug residues that youth producers may overlook is cleaning out the feeders. If a medicated feed is given and the feeder is not cleaned out after, a feed residue will be left in the feeder. Improper injection techniques can also cause drug residues. If a drug is given in the improper location or in the wrong dosage, a drug residue may appear. Additionally, damage to valuable meat cuts can occur. When any medication is given, whether it is a medicated feed or an injection, identify treated animals in some way, such as recording their ear tags or separating them in a special pen. This will help you remember to follow withdrawal times. It is very important to keep good records on drug administration to meet proper withdrawal times, as listed on feed and drug labels. By educating youth producers about withdrawal times, proper injection techniques, and avoidance of medicated residues from feeds, chemicals, and drugs, residues found in meat are at the lowest levels ever and shows the commitment to producing a safe product for consumers.
Okay, so in the video we learned what a residue was. Can anybody reiterate what that is? We also learned what withdrawal time is. Who remembers what that one is? Okay, so residue is the amount of medication that resides in the muscle tissue and is not metabolized by the animal. The withdrawal time is the amount of time that it takes for that residue to be metabolized or excreted by the animal so that there is no medication left in the muscle tissue. Okay? So in our experiment today, that's what we're going to explore. We're going to look at both concepts. So the containers represent the body of the animal. So the big one is the body cavity of the animal, and then this is the muscle represented by the sponge. Okay, and we have holes in the bottom of that. Okay, or you could use a strainer over a larger bowl. Either way. Okay, so our animal is sick now, and we've called the veterinarian, and he said to treat the animal with this antibiotic. So go ahead and treat our animal with our antibiotic. If you have a dry sponge, you'll see it swell. So we're slowly going to inject our animal. And if you look closely, we see that dripping, okay? So that dripping is the amount of medication that is being metabolized, or the metabolite of the antibiotic. Okay, so that's what's going into the animal's body and is being metabolized and being used up and will be excreted or metabolized otherwise. Okay, all right, so now our sponge has stopped completely dripping, but is our sponge completely dry? No, it's still wet, right? All right, so let's go ahead and measure the amount of metabolite. That's what dripped through our container, okay? So I have a graduated cylinder, but if you have just a measuring cup, that's fine. So we're going to carefully put this off to the side, and we're going to measure how much our metabolite. So go ahead and pour that into your graduated cylinder or measuring cup if you don't have a graduated cylinder. So almost 60 mils of our medication was metabolized by the animal. Okay, so that is no longer going to affect the meat quality or the meat of the animal. Okay, so we'll go ahead and pour that out. All right, now we also we said that the sponge or the muscle was not completely dry, correct? So let's go ahead and take that muscle and any water remaining in this tray, Pour it into the bottom one with no holes. And then go ahead and squeeze your muscle out. And all of this antibiotic that's in the muscle still is the residue. Okay? It stayed in the muscle and did not go into the body to be metabolized. So all this water is the residue. It stayed inside the muscle tissue. And if this animal was tested for drugs at the harvest plant, then it would be kicked out because of the residue. Okay, so let's go ahead and measure the residue. Again, measuring cup works just fine. All right, so on this one, we had a little over 90 mils of the antibiotic that remained in the muscle tissue. Okay, so if the muscle tissue had more antibiotic than what was metabolized, how can we, in the amount of time that we watched it drip, what's something that we could have done to decrease the amount of residue and increased the amount that was metabolized? You can go ahead and type your guesses in the chat box, or just holler them out like I'm there with you. We could have waited for a longer period of time, and that would have dripped through. More water or more antibiotic would have dripped through. Okay, so that's the withdrawal time. So it's the amount of time that it takes for the residue, all of this that remained in the muscle tissue, to actually be metabolized or drip through, in our case, to the bottom bucket to be used by the animal's body. Okay, so again, residue, what stays in the meat. Withdrawal time is the amount of time that it disappears and is metabolized. Okay, so one of the things that we can do is to increase that withdrawal time. So the FDA determines what those withdrawal times are for each medication. So thank you for participating, and stay tuned for another lesson tomorrow, and enjoy the rest of the 4-H Live online.